Hello, welcome to the task Hello ThreeJS. ThreeJS is a library that's built on WebGL. As we saw previously, in WebGL, everything is a bit tedious. This is because WebGL is a very low-level library. Right, there are two main interests for us. First is the documentation that we'll be looking at later, and then there are examples. In examples, there are many different demonstrations of what can be done with ThreeJS library. As you can see, animations can be done on 3D objects. Colors can be assigned with vertices, vertex colors, and convex geometry can be rendered with opacity. So there are many options. Now let's look at this code here. The code has two files. First file is for the HTML that determines the layout of your website. For us, we just have one div, which is called my canvas container. And then we have the script file. Here we have a function for loading. So this window that onloads, this will be called by the body onload. That means that if the website loads, this function will be called. And the second function is for drawing a triangle. But let's look at the ThreeJS things first. So let's start from the bottom. We have the renderer, and this has a function render, which takes in a scene and a camera. A quick note about the scene and the camera. So if we have a 3D world with X, Y, and Z coordinates, then the scene is the container that holds all the objects in this world. So cubes, spheres, triangles, whatever. And the camera is the eye that sees the objects. So camera has a certain field of view, and then this is the screen for viewport. So during the rendering of the scene, all the objects that the camera sees are projected onto the screen, and ThreeJS does this automatically. And the camera we define as an orthographic camera, which basically means that there is no perspective distortions. We also set the position of our camera to the 100 on the z-axis, and by default other coordinates are 0. And if you look at the renderer, we selected the WebGL renderer, and then we set the size of the renderer. So this is basically the size of the screen that we want the scene to be rendered onto. And here it is specified 800 pixels wide and 500 pixels tall. Then we have this canvas container. That's the div in HTML, the my canvas container, which is this. And we see that we append the renderer to this canvas container, which adds a child to here. To test our codes, we have to use a web server. In Visual Studio Code, we can use a live server plugin. And if you have the plugin, you just have to press this button here. That will generate a new server on a local host on a port 5500 usually. To get the plugin, go to the extensions tab and search for live server. And it should be the first one by Redwick Day. In the classroom, the server should already be installed, so the button should appear right away. But if you are doing it from your home, then it has to be installed by pressing install button here. Another possibility to get the server is to use Python http.server pip package for Python 3 or simple HTTP server for Python 2. We see that we have a black screen that is 800 pixels wide and 500 pixels tall. And our task is to implement this function throw triangle so that we can see a triangle on this screen. So let's see how can we do that. Task is to create vector3 objects that specify vertex coordinates of a triangle. So 3 and vector3. So 3 is the library that we imported, and the vector3 is an object from that library. Let's look at the documentation for vector3. Let's see how it can be defined. So there is this chapter called code examples, and we see that to create a vector with the name A, we just do new 3.vector3, and then we specify our coordinates for x, y, and z. Let's copy paste it. So we don't really care if it's constant or variable, but I'll set it to variable, and I will put it on the position 100, 100, and 0. And why do we do it at this location? This is because the camera we have positioned onto the position 0, 0, 100, and by default cameras look at the XY plane. Let's repeat this definition for our other two vertices, but let them be in the different positions. Now we need to add those vertices to our geometry, which is defined on the line 30. We have to use set from points function, and the argument is points, and points is an array type. So we need to create an array and put our vertices into this array. Now let's see how this looks like when we print it out. So we have a triangle. Let's see the positions. So we see that the position data is split into individual coordinates. We see that there are 9 positions in this array in total, so 3 positions for each vertex. We see this is 100, 100, 0, 0, 100, 0, and 100, 0, 0. We see that there is also the requirement to fill our geometry with a face, but this is done automatically, although index is null. If we redefine our index to something else, this says let it be like q1 and 0. So those are the indices in the array. So this is 0, this is 1, this is 2. If we use this function geometry set index, let's see what this looks like. So this is now empty. There are no arrows, so why is it empty? So let's visualize it on the whiteboard. We have 3 points. V1 was at 100, 100. V2 was around 0, 100. V3, 100 and 0. So let's say that this is our screen. And the center point is 0, 0. 100, 100 would be somewhere around here. This is V1. 0 and 100. So 0 is the x-axis and y-axis is 100, so that will be around here. V2. And V3 will be somewhere around here. And to get the triangle, we need to connect the dots. The order in which the points are connected matters. So for example, if we have a triangle with faces ordered like 0, 1, and 2, so it will be 0, 1, and 2, we would have a triangle like this. So we see that this is counterclockwise, which means that the front face of the triangle is facing us. So we will see the triangle. But if we change the order to 2, 1, and 0, that would mean that we go to 2, to 1, to 0. So it would be a clockwise triangle, which means that the front face will be looking away from us, which means that we will not see the triangle. So let's specify this in the correct order, starting in 0, then 1, and then 2. Let's see if it corrects our mistake. It corrects our mistake. Finally, this function needs to take into account the position that we feed into this as an argument. So we see this should draw you a triangle with a midpoint and 0, 0. So if we change this midpoint, the midpoint of the triangle should also change. So your task is to change the positions of these to center the triangle at the position given. And also the triangle should be equilateral. And that's the task.